This is our first example on simplifying expressions with rational exponents. And before we do that, I want to review this a law of exponents that we need to use with this problem. And it's this law over here. I'm going to come over to the side. Let's say let's use x, which is simpler. Let's say we have x, y to the second power, and let's say we have a 3. And we have this whole expression raised to the third power. The law of exponents says that we take this power and we distribute it to each one of the factors in this expression, including the number 3. So this becomes 3 to the third power, x to the third power, and y to the sixth power, because remember, when we have a power raised to a power, we multiply powers. That's why this is to the sixth power, okay? And that's what we're going to use here. We have the whole expression raised to the 2/3 power, and we distribute this. We distribute it to each one of the factors inside this parentheses, including the 8. So if we distribute 2/3, this is what we have. We have 8 to the 2/3 power. We have r to the 3/4 power times 2/3 power, right? Because we have a power raised to a power, we multiply powers, and we have s to the -3 times 2/3 power. So all we've done for our first step is distribute this exponent to each one of the factors. Okay, 8 to the 2/3 power. I'm just going to keep this like that for now. We'll simplify it later. I want to do this multiplication. R, when we multiply fractions, we multiply numerator times numerator, denominator times denominator. You can also simplify by canceling the terms. The numerator can cancel with this denominator, and this 2 we can cancel with this 4. And you can simplify this. Or you can just multiply numerator times numerator, denominator times denominator. If I work with this here on the side, this is what I have. I have 3/4 times 2/3. I can cancel 3 and 3 and 2 and 4, and I have a 2 here, and this becomes 1/2. Okay? Or you can do this. You can multiply numerator times numerator, denominator times denominator, and then reduce, which is 1/2. Either way, you get the same result. Okay? So this becomes r to the 1/2 power, and this becomes s, and we have -3 times 2/3, and that gives you numerator times numerator, that gives you -6. Denominator times denominator gives you 3. This gives you -2. So this is s to the -2 power. So far, this is looking very nice. Now what I need to do is take 8 to the 2/3 power and try to simplify that, and also get rid of my negative exponents. Anytime we're working with exponents, we never want to have a negative exponent in my expression. Okay, so to get rid of the negative exponent, this is what we do. Whenever we have a negative exponent like s to the -2nd power, I can make that a positive exponent if I bring this s down into the denominator. Okay, so that's what I'm going to do here. This is going to become 1 over s squared. Now 8 to the 2/3 power, I can rewrite this as a radical. And if I write this as a radical, remember, we take our 8, which is the base, that becomes our radicand. The numerator of this fraction, that is your exponent, and the denominator, that is your root or your index. Okay, the same thing for r. R to the 1/2 power, I can rewrite that as r. And s to the -2 power, that's the same thing as 1 over s squared. Notice all of these are part of the numerator. This expression times 1. That's the numerator. In the denominator, I have a 1 here, I have this over 1, and I have this over s squared. So when I multiply numerator times 1, I get the same numerator, and then the denominator is s squared. So this is the same thing as the cubed root of 8 squared times the square root of r times 1 over s squared. Now I can simplify this. 8 squared is 64. So this becomes the cubed root of 64 times the square root of r over s squared. And the cube root of 64 is 4. 4 square root of r over s squared. And that's how this problem ends. This original problem becomes 4 square root of r over s squared. In our next video, we're going to do another example. We're going to do a total of 4 examples. Okay, so this is example 1.